Treehouse Software has been a mainframe software company since 1982. And in recent years, you've probably seen that our main focus has become the mainframe to cloud data replication with our TCVISION product. We're partnered with all of the major cloud providers, including Microsoft Azure. Now for this presentation, I'd like to introduce Chris Rudolph, our TCVISION product manager, who will be giving the presentation as well as a live demo of the product. And we'd probably, since we're recording, we would prefer you hold any questions until the end, or you can post them in chat, and one of our technicians will answer them along the way.
Yeah, so thanks, Joe. And as he said, my name is Chris Rudolph. I'm the TCVISION product manager. I've been working with the product since about 2008. As we at Treehouse have been helping all kinds of mainframe customers move data to off the mainframe to other environments, and most recently the cloud. TCVISION is a really great product because it allows people to extend their mainframe and take that data where it needs to be. And there's all kinds of things they can leverage being able to move that data using TCVISION. So what you're seeing now is a list of our TCVISION supported sources and targets. And as you can see, it's quite extensive. We pretty much support all of the databases on the IBM mainframe platform on both ZOS and ZVSE, which are the two major platforms for IBM these days. So that's DB2, IMS, IDMS, VSAM, Software AGs, Adabas, DATACOM. So pretty much all those databases, including flat files we handle. And then you can see on the open platform side, all the standard, relational databases, SQL Server, Oracle, Postgres are all out there. And now on the cloud, we also have full support for the Azure cloud offerings with the Azure SQL database, Postgres database, blob storage, event hubs. So TCVISION, as you can see, is kind of a Swiss Army knife being able to move data from a lot of different sources to a lot of different targets and back again. So the first part of this presentation is going to kind of focus on the TCVISION architecture, and then we'll look at metadata, how we move the data, and therefore jump into the live presentation. So at a very high level here, we're going to have TCVISION running on both the mainframe and on an open platform someplace. That open platform could be up in the cloud. It could also be on-prem as well. So here, maybe a graphical view of how the system works. So on the left-hand side box here, this is our mainframe, where we have a TCVISION manager running, and it's able to work with whatever the mainframe database is, and it works at a native level, the same way a mainframe application would work with the database. On the right side here, we have the Azure environment, where we have our TCVISION manager running. The TCVISION managers are able to perform all the change data capture and the transformation of the data from that mainframe format to whatever the target environment is up in the cloud or on-premise, and then apply the changes to that database. So whether it's going, sending SQL to a Postgres or Azure database, or if we're sending JSON information to the Azure Event Hub or Azure Blob Storage, TCVISION is able to work equally well both in a cloud environment and on-premise. And then controlling the whole thing is going to be our GUI control board, which runs on a Windows desktop someplace. The neat thing about TCVISION, as we work with our customers, some mainframe customers are very forward-thinking, and they say, sure, we want to connect our mainframe to the cloud because that's the most effective way for us to be able to transfer that data with that cloud connection. We have other mainframe customers who are very conservative, and they say there's no way we're going to have our mainframe talking to the cloud at all, so we want to have an intermediary server on-prem. And that's kind of where the TCVISION manager comes into play here. It's just performing all the change data capture work, all the applying to the target sides, and from our standpoint, we don't really care where it lives. It just has to do its thing to send the data up to the cloud. Now, what's actually going inside these managers is this next slide, where we have our TCVISION repository. And this contains a list of all the rules being used by TCVISION. So this is going to be the rules for the metadata, what the layouts are for our VSAM file or for our Oracle target. All the replication rules and type of filtering will all be in this repository. So as our TCVISION components then are moving data from the mainframe to the cloud and back from cloud back to mainframe again, this repository is going to be used in each step of the way. And then we interface with the repository either through our GUI control board or through the TCVISION command line utilities. So that kind of gives you a little overview of where things are running and kind of what's happening behind the scenes. Now, from a user perspective, this control board here is the main way you have interfacing with TCVision. It's a product that handles mainframe replication, but there are no green screens. Everything is done from this GUI environment, which is great because for a lot of customers, the mainframe staff are have limited amounts of time and overtaxed, and it's nice that you can have people who are not mainframers use this control board to be able to work with the data and to be able to move the data where it needs to flow. So what you see and what you'll see during the presentation or the demo part is this control board. It really services as a single point of administration for the entire product. So anything you want to do with the product, whether it's going to be importing metadata or making changes to the metadata, setting up replication scripts, monitoring, looking at log files afterwards, can all be done from a single point of administration. So when you first get the product installed and you have it up on the mainframe and in the cloud, the very first thing you do is go through a modeling and mapping exercise. And this is the part where you tell TCVision about your mainframe environment, and you tell it about the target environment you want to have. In some cases, our customers are using the importer to read in whatever the copybooks are, the mainframe metadata, and it builds out for us the target environment. In other cases, there's an existing target environment, and so our importer has to import from whatever the existing SQL Server layout is, and then do all the linkages between that and the mainframe data source, what it might be. Within this modeling and mapping wizard utility, we have a series of wizards available to help with normalization, denormalization, substrings, specialized date-time formatting, setting up filters for record types, either at the record level or field level, as well as doing conflict detection for bidirectional environments. So these are the things you can do with our repository, and I have a couple screenshots here showing these various parts. The import process, this here happens to be coming from a DB2 database as the source. So you can see we have our schema name, all the tables are underneath the schema. We can check any of these we want to import. We have a little superscript 1 here indicating that we have change data capture has been activated to this particular table. But if there's VSAM files, we use whatever the native metadata is for that database. So copybooks, data dictionaries, PSV layouts, TCVision is able to handle them all. And what is generated is something that looks like this inside of a repository, where on the left-hand side is what you see coming from our mainframe source database, and on the right-hand side is what's going to the target. So in this case here, it happens to be going from an database file, which is a hierarchical type of database similar to sort of a VSAM file, going to our target relational database, which in this case happens to be Oracle. So you can see TCVision has taken all the names from our metadata. We can double click on any of these names here, column names to get more of the meta information on it. We can double click on any of the lines to see any of the wizards, if there's any type of filtering involved. Over here on the target side, we can change the keys if we want. You can see we have a shaded field here, which indicates a repeating field group. So what TCVision does is it's able to break it off into a child table and set up all the primary foreign key relationships. There's some buttons we can click on the repository piece and automatically generate the DDL statements to apply this to the target system. It's also available as well to run one of those TCVision utilities to build the DDL and send it to the database that way as well to be able to generate the tables. All of the index information, all the key information from the repository will be created as part of the DDL and applied to the target system. I mentioned earlier there's various wizards involved. We have a screenshot of some of the wizard options we have, and we can set up conditions to do filtering of data. So if we have record types in VSAM, or there's other conditions you only want to send data based on a date, you can do the filtering. You can also do processing rules. So if there's things you want to do, such as concatenation values, perform date time mappings, some type of numeric functions, are all available within this wizard. And we'll look at this a little bit more during the live demo part as well. So we saw so far the kind of a unidirectional going from database to SQL Server or Oracle, but there's also a lot of functionality built into the product set, so you can do bidirectional replication as well, and some kind of graphical views of this, where we can go one-to-one, one-to-many, many-to-one, many-to-many. So if you have scenarios where you're coming from a VSAM file and you're sending the data to a parent and child, but now you have to get the data from the parent and child back to the VSAM, you can do that with some of these different replication scenarios. We also have these two other ones at the bottom mentioned, data warehouse and journal replication. The data warehouse replication is well suited to environments or applications where data is purged on a frequent basis, but there's a need for reporting purposes to hold on to that old data. So maybe like a logistics application per se, or some warehousing application. So what TCVision is able to do, instead of just mirroring the data in the target environment, instead it sends off an insert for every time the transaction occurs on the mainframe. And that new data being added to the target side is going to show the data as it now currently exists on the mainframe, a flag to indicate what's currently active, and a timestamp of when it changed. So you can have a whole history of all the changes taking place. And then the journal replication works in a similar manner to generate an audit trail for the data replication. This can be especially important in bidirectional scenarios where new applications are being generated, and the new application does something that causes the old mainframe application to break. And it could be something as simple as, the new application uses lowercase and the old application uses uppercase. So with this data warehouse replication and journal replication, your programmers can have an audit history of all the transactions flowing up to and from the mainframe, so that you're able to easily remediate the data and get the mainframe application working again. The other thing which is built into TCVision is conflict detection, and this is used whenever there's a possibility for a collision to take place in a bidirectional environment. So you can have TCVision specify a series of rules of how you want to handle the conflict. And that conflict could be something as simple as, you're trying to do an insert, but there's already data there. So do you want TCVision to stop and flag an error? Do you want to ignore and continue going? Or do you want to change the insert to an update and continue replication? Similar things with updates. You can change updates to an insert. You can have the product do a validation check on all of the existing column values to ensure they match the before images of the incoming update before you make the change. Same thing too for the deletes. So it's really quite flexible in how it's able to handle the conflicts. So this is kind of the piece here, is the kind of the once over for the TCVision repository. Now the next part of the presentation is going to look at moving data. And the first thing we have to move data is our initial load. We also call this a bulk transfer in TCVision. And this is the part where TCVision is going to read whatever the database is up on the mainframe, or it's going to read an unload of the mainframe database and process that data. So this could be a live read of Adabas or VSAM, or it could be someone performing a DB2 image copy or a DB2 unload, transferring that over to the manager, to the open platform side where the TCVision manager is running, and applying it to the target system. So there are wizards that assist with the creation of these initial load scripts. The process itself is going to handle all of the transformation from the mainframe data types to the target side. All the ASCII EBCDIC translation will be performed as well. There's no need for any type of special middleware. TCVision is going to handle all of the transformation and the delivery mechanisms itself. The only thing you're going to need are the native loaders and drivers for whatever the target system you have. So if you're going to be, bulk transferring data to SQL Server, you'll need the SQL tools, or Postgres, you'll need the Postgres driver. So TCVision is able to do this for you either on a scheduled basis or as a one-time initial load. So once the data is there, TCVision then has to go through a series of CDC replication. So the CDC piece, TCVision is going to use whatever the database log files are. Or in the case of something like a VSAM, it's going to use CICS. It's going to analyze the transaction logs to see where the data is. So you can see in these two examples here, we have a begin transaction, data is being added, deleted, changed, and then it ends. So TCVision is specially designed to ensure that only committed transactions on the mainframe will be applied to the target system. So if you have a user that goes off to lunch after they hit enter, and then their transaction is rolled back by the system, TCVision will never send that data to the target side. But once again, for the data replication, we're looking at the transaction logs. We're using all the same rules for replication that we use for the bulk load. So once again, we're handling, all the delivery mechanisms, no special middleware requirements. We're going to be performing commits at the same level that the source system applies them. So if you have a user that's online user making changes, one at a time with a commit, versus an application and batch that does 1,000 at a time, whatever that level may be, TCVision is going to be using that same information when it applies the data to the target system. It's also going to use those same rules going back again. So if you have need for bidirectional, some customers do, some customers don't. TCVISION will be taking all of the transactions from whatever the commit level happens to be from the Azure side, going back to the same repository information to apply to the target system. There's looping prevention built into the product so that you don't have to worry about an endless loop where mainframe makes an update, goes to Azure, Azure makes the same change, goes back again. TCVISION is specially designed to prevent that looping from taking place, as well as performing any type of conflict detection that are going to be specified in the rules that were shown earlier. So I'm on to my last slide right now before we get to the live portion, and that's the stage processing approach. I've been mentioning a couple of times now that TCVISION is able to perform all the transformation on the open platform side instead of the mainframe. And this really is a great thing for customers because it introduces a lot of cost savings. Now, it's pretty typical for clients these days to be running their mainframe pretty close to 100%, and there just isn't CPU available for additional overhead. So what TCVISION is able to do is capture the changes in the initial format and then perform all the actual data transformation on the open platform side or up in the cloud. So how that works, and the data has to go through the stage process. So in stage 0, TCVISION is going to be reading the data as it exists from the mainframe, whether that's going to be from an unload data set or from a live database or from a transaction log someplace. That's how it's being captured in stage 0 and transferred to the TCVISION open platform in stage 1. And this is where all the ASCII EXODIC translation is going to take place. There's a queuing mechanism built into TCVISION where it's going to temporarily queue those files into a data object we call pipe. And then from there, TCVISION will process it from stage 1, which is based on the before and after images, based on the source metadata layout, to stage 2, which is going to be normalized based on the target definition layouts. And finally, in stage 3, TCVISION is going to build a SQL DML or JSON or loader files it needs to apply those transactions to the target system. And the process is going to work fairly similar going back the other way as well. So if we have to capture from Azure, we'll go through the same stages as well. The only difference is going to be we're going to perform stage 3 processing on the open platform side. So we have pre-built all the native calls for our mainframe database, and then we'll send those calls pre-formed up to the mainframe. So there's no additional processing taking place in that environment. So I'm now going to exit out of the TCVISION presentation here and go to the control board. So what you're seeing currently is the TCVISION control board, and this is sort of like the single point of administration I mentioned earlier. That's used to administer TCVISION for all the metadata imports, for all of the transaction processing, log viewing, etc. So what you have on the left-hand side is our existing environment here with the mainframe, and in this case here is a TCVISION running on-prem in a Windows environment. What we have on the right-hand side is our active replication. So the scripts we see running here on the right, that's where they're defined on the left side. So what we can do is just double click on any of the items in here, and we can see additional information. In this case here, it happens to be our mainframe manager. So we have our job name, we have our load library information, some version information for what we have for that system. We can also do the same thing here for our Windows box and show it. And so we have, our Windows name, some information about the process that's running, configuration directories, version information, etc. And so this is kind of an easy way just to view data from different systems. We can see some log information here from the mainframe side with the sysprint. Maybe something was running earlier and wrote some stuff out. So we have our log data here for both the mainframe, and we can do the same thing as well on our Windows side as well. The active scripts that are running, we can double click on them to see additional information. In this case here, it has to be pulling data from an Adabas plog, Adabas being one of the databases we support up on the mainframe. So we have some information about the plog itself we're getting from, that's the transaction log, some record counts in, records counts out, timestamps of when data last flowed through the product, as well as on the mainframe side. We have a script receiving changes from the mainframe and queuing them. We talked earlier about the stage 0. This is actually getting the data from stage 0, and it's going to queue it in something called a pipe in stage 1. And finally, we have our script that's reading for the pipe, and this is responsible for applying transactions to the Azure database. And this is something we'll look later in the live demo, make some changes, and we'll see the counts going up. On the left side here, we'll take a look at the metadata repository first, since that's kind of where a lot of the action is. And what you're seeing, if I kind of drill down here, are some of the different sources that TCVision supports. In this case here, we know Adabas, IDMS, and SQL, and then we also have a series of target definitions applied. So if I expand Adabas, we'll drill down. I have a number of Adabas files defined, and we can pick this particular one here, the employees file. And we'll open this up in our repository editor. Let's shrink it down a little bit. So what you're seeing here on the left side is our Adabas file, and this is information coming from the layout we had up on the mainframe. So we can double click on it, and we can see different information in terms of the code page information and any Adabas specific information here, which really isn't any. And then we can double click on the individual columns and see some information about the metadata type, whether it's going to be a fixed character, or in this case here, it's some type of integer information. We have these particular fields here which are shaded. This is an indication we have a repeating field group of some kind. So we can advance one forward and see our field information properties, some links. We can also click on our subtable icon and get some information about the max number of occurrences in our repeating field group. We can do the same thing here on the right-hand side. We can double click on these fields to see information about the column types that are out there for the metadata. And we can also click on the lines themselves. And this pulls up the wizards I had mentioned earlier that we use for our filtering of data. So if we want to filter data based on a particular record type or a date, there's a series of pre-built rules we can use. So if we want to set some type of roll up based on a particular field, we're looking for a value, or maybe we want to pull a regular expression handler. We can specify some information here, what we're looking for from the regular expression. We can do this at the record level or also the field level as well. So there's particular fields you want us to do filtering on, you can do that through the use of the condition. The processing rule is a little different. This actually allows us to manipulate the data coming from the source side. So we have options here that we can set a value. And if we want to specify maybe a timestamp of processing, with the timestamp whenever TCVision sees the transaction coming through, from the time the change happened on the mainframe database, or the timestamp when it was committed by the mainframe database, or whenever TCVision processed it. We can also do lookups based on other values as well. We can do things like SQL lookups. We can call off to other programs, other libraries. There's other functions built in for manipulation of data. So doing truncation, concatenation, change, replace, date, time changes. So if you have, it's pretty famous to have on the mainframe side, numeric or alphanumeric fields, which are 6 or 8 characters long, digits long, and you have a year, month, day in there. So with TCVision, you can specify a presentation pattern that you want it to use and then write off to a date. We also have some predefined format strings as well. So there's a particular timestamp you need, or maybe it's a system type clock you need to pull and have translated. TCVision is well able to handle that. The other thing we can do here from our repository is we have a little book icon, and we can click this, and this is actually going to go and build out and create all the DDL structures for us to drop and create on the target system. So what I'd like to do right now is we'll step to the import process, give you an idea of how that looks. So select import for a wizard, and this is how we get more metadata into our repository. So we're going to check for the input, whatever that source is going to be, and then we'll have TCVision generate the output targets as well as the replication, specify our group, and we'll select our target we want to use, SQL Server Replication. Just some note about targets. We can also see some information about the target we're going to. So if we click over here, sorry, everything's something on my other page here. This happens to be our Azure database that is set up, and we have our TCVision DemoDB database we're going to write to with our user information, and then we can do a little connection test and validate looks okay. Say finish. We have our loopback protection here, so if there's doing bidirectional replication, anything that we see coming from this particular schema, TCVision will know which transactions it has created, and will not send those back to the target system again. So we have that definition in here. I guess I should also mention one other thing. If we want to create a new definition, this is where we come in and we specify our Azure data type. And then we have options for doing, what the database is going to be going to: MySQL, MariaDB, Azure SQL Database, Blob Storage, Event Hub. And then based on the information you specify on that screen, it's going to go through and ask you a series of questions. So now that we have our connection to our output target being specified, we'll say next. And now TCVision wants to know what our source is going to be. So in the case of, let's say, Adabas, we'll come out here and specify our database information. And then TCVision is going to give us a list of all the available files it finds off in our metadata repository. We do the same thing too if we've selected to be like a DB2 from our group. And TCVision is going to go off and query DB2 and give us a list of all the various tables it sees, and we can check the ones we want to import into our repository. So it gets asks us information about the code pages we want to use. So we can specify a mainframe up-to-date code page for the DB2 data, as well as a UTF-8 or 16 for our target system. Any type of information we'll put if there's a special creator we want to use, or if we want to have a naming convention, we can specify this. Also the case level, so we can have TCVision change things to lowercase. Once I finish, and then TCVision is actually going to go through, read that DB2 metadata, and add these to our target system. For things that already have keys in DB2, it generates the keys. For items that don't have keys in DB2, there's no key being generated. But kind of the point is that regardless of whatever the source data type is, we still have the same look and feel where we were able to see all the meta information coming through. So that's the metadata repository piece. Once we have the items defined in here, we're now ready to actually start moving the data. And so some of the ways to do that is through the bulk. And earlier today, I was doing some bulks with TCVision with SQL Server. And so this is an example right here of the script that's being used when we're actually rolling data from a mainframe side and applying to the target. So if I go to my target database here, currently have some data. And so we'll just kind of step through the same exercise. Where we'll go and we'll actually create our tables. And before I do anything else, I just take a look. So we have data currently in our employees file. So we'll drop in and create the tables. And so see the tables are going down. And then TCVision is going to go through and perform the updates. So as we're stepping through this exercise here with creating the tables, are there any questions so far from the things I've been showing you?
Hi, Chris. I have a few questions.
Okay.
So the first thing is like, so whether the replication is kind of a real time or near real time from source to the target or from target to the source?
Yes, and so it's based upon how quickly we're able to capture the transactions from whatever the source is going to be. So in this environment that we're looking at right here, we're pulling from Adabas. So we're looking at transaction log, and we're pulling it every 600 milliseconds. And that's pretty typical for Adabas and IMS and IDMS. It's possible to increase to decrease that pulling frequency, but there are some have implications for doing that. So we usually stick around 600 milliseconds.
Okay, so if we can say like from source, from target, probably the statistics says it takes around 600 milliseconds.
Yeah, so that's the capturing and then queuing it on the open platform side. And then the big question you have is how much latency is they're going to be applying the changes to the target database. Prior to the cloud, that was always the bottleneck, just because you'd have this mainframe database that could go crazy and generate lots of activity. And on-prem, relational databases typically were just not as fast. But now with all the scalability that you have in the cloud, the way you can scale like an Azure SQL database, that's really not so much of an issue anymore, just because those databases would be so much more powerful than they were in the past.
Okay. My next question is like the TCVISION agent, which you mentioned in one of your slides, is running on the mainframe. So if it's running on ZOS, whether it's running on a separate VM or it's running on mainframe itself, or like as a separate.
Yes, if I go back to my architecture slide here. So this TCVISION manager right here, this is running on the mainframe. On ZOS, it's running as a started task. And on VSE, it's running in the partitions. This is actually physically on the mainframe. This other TCVISION manager here, which in the case of our little demo that we're doing, is running on an on-premise Windows, but it can also be running in the Azure cloud. And that could be either, an instance running using Windows or Linux. So TCVISION runs on both of them. And this is the place where all the transformation of the data is taking place. So as we get the mainframe data in, we just transfer it however we get it, and then perform on the transformation on the system here, and then apply to the target side.
Okay, so actually my question was like if the TCVISION is running on mainframe, right? So whether I just want to understand. So whether there is something which it uses the zip or whether it consumes some MIPS here, because like whenever people want to move out of mainframe, right? Say they want to see the MIPS reduction here. So I just want to understand whether it runs on whether it utilizes the MIPS, the current MIPS, or it runs on the zip, which can able to lay off some MIPS.
Yeah, I understand what you're saying. It does not use zip. It's just running on the general processor.
Okay.
So of course you do have some overhead because it's on the general processor, and that's the way we mitigate it is to not perform any data transformation over there. Because that's really kind of the expensive part, is transforming the data. This process you see right here, where TCVISION is reading data from a log file and transferring it, is largely an I/O process involving disk reads and TCP/IP. There's no actual additional processing is being done. The same thing too, if we were to write data back to the mainframe, we generate all the transactions on the Windows side first, or the Linux before we plot them to mainframe. So there's no overhead being built and generating a native transaction that's already pre-built, ready to be applied to the target system.
Okay. Okay. Good.
So when you start looking at where's the CPU being used on the mainframe, the one thing is during the initial load for sure, because TCVISION has to query that database. So that's the point where if you can unload that mainframe data using whatever the database utilities are, and then you transfer that down to the open platform side, essentially you're doing a free bulk onto this target system without impacting any type of mainframe resources at all.
Okay. Okay. Fine. Sure. Thanks. The another question is regarding the IMS database. You mentioned like you have the rules in between the mainframe and the target. So in IMS, it's like hierarchical database, right? We have DBD, PSB, and PCBs and kind of stuff. So whether these rules in between converts these hierarchical into a relational, and then it maps all the metadata from there, and it puts that into the respective target as a table, record, or columns. Is that the rules? Is that how the rules play here in between for the IMS database?
Yeah, I mean, IMS is a little tricky because it's hierarchical, and so sometimes things don't go into like a neat relational format just because there's two different data types. So a lot of customers do is they take that IMS data and put into a series of staging tables, and the key thing being that you have the correct keys as you're going through for IMS. Just so in some cases you end up having the keys propagated to multiple tables, just so you're able to have the whole chain looking correct.
Okay, so if it's staging table, yeah. So if the customer is going to use the staging tables in between, means like they'll be offloading to a kind of a temporary relational database, and then they move that to the target.
Yes, that's correct. And that's the way people have been doing it for a long time. But I will say that recently we've had some customers showing interest in pushing that data from IMS, or actually not so much IMS, but Adabas, to like some type of queuing, so like a Kafka or an Event Hub, or to a blob storage. And so in that case, you're just sending JSON for whatever the data is coming from the mainframe, which, you think about hierarchical data and JSON, they're sort of, kind of very similar in that instance. And so now they have that JSON, they can do whatever with it, what they want. So that's the other thing that some customers are now exploring, is using that as an option. But for a lot of these applications, there's a couple things happening. There's a need for reporting, and there's a need for some type of modernization. So by going to a staging database, sometimes these things end up having multiple uses, both by a migration team as well as a reporting team.
Okay, fine, sure. And I have like one more question. Sorry for asking one question.
No, that's okay. That's why I kind of paused here to see what questions you might have. So go ahead.
So you mentioned about the contention, right? The TCVISION can able to see the contention happening for data warehouse replication also. So my question here is like probably with Synapse or with Google GCP BigQuery, anything. It doesn't have the support, or not support. It doesn't have the primary key kind of constraint there. But in the source, we have the primary key constraints from DB2 side or from the other side. So when these data move from the source to a primary key, so probably like when they want to enforce the primary constraints on the target, and in DB2 LUW, right, in the source, there'll be no primary key, or that you don't have primary key on the DB2 data warehouse part. So when they impose a primary key on the target, so whether it kind of does a contention, whether the TCVISION can able to handle the contention, or it just allows to land on the target.
Yeah, so if you have scenarios where you have data that doesn't have unique keys on the source, and you're trying to go to a target that requires unique keys, for sure that can be a problem. And that kind of comes down to, that kind of comes down to a question of, put TCVISION aside. What do you want to have happen in that scenario? Like, if you have like, I don't know, like a VSAM ESDS file that doesn't have primary keys, in some cases, just the key part, the important part is just getting data transferred off the mainframe. And then once it's over on the target side, the application user can decide how they best want to handle it. And so I guess you could certainly have, you could use like a trigger or some other mechanism for applying a key. But then the important thing is, now if you need to replicate that data back to the mainframe again, what type of keys you're going to have. And so usually there's no one size fits all type of answer to that sort of question. It kind of comes down to sort of what makes most sense for the application. And it's something that might vary, even like if you have multiple VSAM files, it might vary. What's correct for one VSAM file might not be correct for another one.
Okay.
So
okay.
That's kind of thing we run into is each of these mainframe systems are different. And so sometimes you have to do some type of customized solution to have the best fit for the customer.
Yeah, sure, got this. And one last question from my side. You mentioned like you do in the initial load only from backups and images, right? So whether you do support the tapes and virtual tapes kind of stuff from source?
Tapes?
Yeah, tapes.
Yeah. If you would have a tape, yeah, TCVISION can read a virtual tape.
Okay.
Yeah, because we have our mainframe piece, and that's what I'm going to show you here is this data load to SQL Server. I have set on here this data set, but that's actually something what I did was on the mainframe. Oops, sorry, go to the Treehouse mainframe, and I previously ran a job. And the whole purpose of this job here was to read an Adabas file, and we specified in here the if we go down to the file number we want to unload, and then TCVISION unload the file for us. So I did just an FTP do it to the local system, which is what I have here, and I have my information going to Azure. I'm going to use the SQL loader, and then my connection information here for the database. And so what we can do is actually run this. process. And it's kicking off right there. And it's writing some data out. Maybe I'll see some stats if I catch it in just the right time here. Oh, looks like it was too fast for me. But now if I refresh my information out here, I now have some data coming from my file. We have all the data here that was loaded from the bulk, as well as also being able to see some information in terms of, like, records that are loaded by our bulk transfer. So that's in the case here where this, running this database utility is something that the customers have to do all the time on the mainframe. And because it's a utility-based process, it takes very little CPU. So the whole way of, of doing this can be a very efficient means of transferring the data versus having to have TCVision physically read the database. And now it's like an application that's having to spin through your entire, database on the mainframe side.
Yeah, sure, Chris.
Take a look at some of these. Take a look at some of the scripts that are actually moving the data. They're sort of working in a similar fashion. We're specifying the log information here that we have concatenated. TCVision has a little chooser we can go through. This actually allows us to see the data sets up on the mainframe. So just another way that TCVision helps you with not having to use a green screen. So if you have people who aren't mainframe savvy, they can, but they're working with the data from the target system. This is a great tool for them to be able to get the mainframe data they need. They might need to ask the DBA some questions, but they're able to be largely self-sufficient for setting up their process for the replication and for the bulk. We have our output level here of 0, which means to take the data as it comes. We specify our IP information for the target side we're listening on. Like I said, this is on-prem, but if we're going to the Azure cloud, we just have our connection information here to that database, and then the script we want to run, and our structure information pointing back to our metadata repository. So we have that connection link between them. We can select in here any types of what items we want to be capturing from. So if we were doing something like a DB2 for our source, we would have our DB2 log record, and then we would have whatever values in here that we would want to be using that correspond back. And so the similar thing too with the other scripts. We have ones that will be capturing the changes, and this script here, let's probably want to show. If I can maintain. So we have our area. Essentially, we're receiving data on a listener report, and they're going to be queuing to something called a pipe. This is just an area in file storage where we're going to be temporarily storing the transactions. So if you'd have any type of interruption in the network between the TCVision and the target system, we'll just queue all the transactions here on the operating system level. And then finally, we have the piece that's going to be reading from those same pipe files and applying to the target. We also have some SQL logs here that we can activate. So for auditing purposes, good transactions, failing transactions, and then informational messages. So we do, some type of duplicate keys or updates with no insert, that type of information we can capture. So take a look at some of the stats here. Right now we have, I think, 178 out, 120 in. So what I'm going to do is go up to the mainframe now. And my colleague has written a little program here for me. And so this is going to be for 213. So I go ahead and I'm just going to run this guy. Before we do that, let's take a look at the data on the where. Okay, so we have this Peter guy, and I should mention too that this stuff on the mainframe has changed a little bit since I last took that unload. So this existing mainframe data might be slightly different. If I type in Joe Rogan over here, and I'll go ahead and run this.
Thank you.
Oh.
Run. Yeah, there we go.
Did I type in sub? Okay, there we go. So we have before, which I guess was Kevin Heimbaugh, now is Joe Rogan. And if I rerun my query over here, maybe I have to enter for it to complete. There we go. All right, so looks like we captured changes, and I don't see my running script here anymore. So it looks like we lost our connection to the remote host, so let's go ahead and restart it again. And if we do our information, now we see the changes coming through. And there's our 10 updates. So we can actually go through and we'll stop the script and take a look at those. And under normal circumstances, for kind of a production level environment, what you would have would be, various, restart scripts and some other things to kind of keep alive. So we don't have a dropping of the script like that. So if we go out here and we'll take a look at our logs. So that last one. Here's our Joe Rogan transactions that went through for 213. And we shall finally now see our information changing over here. I should mention too that Joe Rogan's not that Joe Rogan. It's one of my colleagues who's on the phone call here.
Thank you.
But it's great for him to get good tables at restaurants. So what we can see here is information about the database that took place with Adabas, database information, the file number, user information, and it's information as well from the plog block offset. And so this information we have here is really quite powerful because it allows you to link up to whatever the source system was. You can say, I can see the data that changed, and I know what exactly took place on the mainframe side or on the relational side to make a change. So you have that kind of that one-to-one link. So with any type of questions at all, you can know exactly when it happened, and where it happened. So if we're pulling from SQL Server, we have the LSN information. And then of course you also have all your commit, no commit updates, and then various info logs out here as well, showing type of suppressed data that was sent. Some other stuff in here as well. If there's any type of correction of invalid data, we'll see that information in here. Any type of performance improvements that can be made, we'll see some metrics about sizing for the environment. So hopefully it kind of gives you a little bit of an overview of what TCVision is doing, how it's able to handle the metadata requirements from many different mainframe databases, how it can do all the mapping. You can configure it for bidirectional replication. You can use it for initial loads, and then the ongoing change data capture. So, Joe Brady, is there anything you'd like to add?
If there aren't any more questions, do you have any more questions?
Yes, I do. Sitaram Raman already asked some of the questions. I have a few. Okay, so in your presentation, I see you mentioned you do bidirectional replication as well, right? So is this bidirectional has support for VSAM and DB2 both?
Yes, that's supported for both of those. Pretty much, if I get back to that slide I have earlier, and this is also on our website as well.
Okay.
But pretty much anything you have here, these are all supported for both source and a target.
Okay. And how do you have a conflict resolution mechanism if there is a conflict in case of bidirectional?
Yes, and that was the part earlier in the presentation here, to get back to it, where TCVision is able to determine if there's set up a conflict taking place, like an insert, but there's already data there, or you're trying to do an update but no data exists, that you can have TCVision determine what it should do to resolve the conflict, whether that's going to be, changing an insert to an update to an insert, or if you want to send some type of alert out, or warning, or stop the process. So there's various action items you can do if a conflict is detected.
Okay.
And that works the same way for any source, any target. That we you have these options to either try to remediate the issue and continue processing, or stop or just ignore and continue.
Okay. And for VSAM, right, support, do you support the complex copybook structures like redefines and occurs?
Yes, of course.
Okay, great.
And that's one thing I should mention about the copybooks is that they can give you a number of headaches, because if you have a very complicated environment with lots of redefines or occurs, and you're trying to denormalize everything, you very easily can have more columns that are supported by any relational database. I've seen where a copybook blows out to 5,000 columns if you're trying to denormalize everything. But yet, if you have nested occurs and everything else, having to go with a normalized approach isn't always best either. So that's another situation where some customers would like to use JSON for the VSAM, and then process the JSON from the VSAM.